In section 4.3, what we're adding on to the testing stuff we've seen so far is the concept of what's really our formal decision. So we've looked at the idea of a p-value, which is telling us a sense of how extreme is our sample value or how likely is our sample value to occur if the null is true. If our sample value is really far out in the tails of the distribution, it means it's not likely to occur if the null is true. If our sample value is in the middle, it is likely to occur if the null is true. So the p-value gives us that sort of sense. What we want to do then is use that p-value to make a formal decision. Do we get rid of the null and say it's not likely, or can we not get rid of the null? So for our decision, there will be two conclusions. You'll either reject the null, and that would be if we had an extreme sample value, which produced a small p-value, or we do not reject the null, or we fail to reject the null. And that would be if our sample value was not very extreme, or we had a large p-value. So then the question is, what is considered small or large when looking at a p-value? We compare a p-value to what we denote as our significance level, alpha. And so alpha is typically set at 0.05, or sometimes 0.01 or 0.1 are used. If there's not a significance level stated anywhere in the problem, it doesn't tell you which significance level to use, you can assume that you're supposed to be looking at the most common value, which is alpha 0.05. So what we do is look at our p-value. If our p-value is small enough that it's smaller than alpha, which is usually 0.05, then our decision is to reject the null. And in that case, if we're able to cross off the null, we do say we have significant evidence of the alternative. If our p-value is greater than or equal to that cutoff of alpha, we would say we don't reject the null or we fail to reject the null. And in that case, we don't have evidence of HA. So our first part, either reject or do not reject the null, is just a quick statement. And then in terms of words, we're going to write out this part. We have significant evidence of HA, or we do not have significant evidence of HA. And when we write that out, we're going to write it out in context. We are not going to simply put HA in our conclusion. We're going to write it out in terms of the study. What are we finding in terms of what HA meant for the study? So we have some examples on the next page here, and I have these already written out. I just want to run through these. And so in 4.3.1 and 4.3.2, we're looking at the same set of three studies. So I'm going to do these in tandem right now. Okay, so in this example, we have resveratrol, which is an ingredient in red wine and grapes. It's been shown to produce weight loss in rodents. And so we have a study that investigates whether the same phenomenon holds true in primates. So we have 6 lemurs in the sample. They had their resting metabolic rate, body mass gain, food intake, locomotor activity measured. And what we're looking for is before and after the treatment. For each of the following, we want to use the p-value we're given to make the appropriate conclusion, which at this point we're just going to say reject or do not reject or fail to reject the null. Then in the other example, we have the interpretation in terms of do we not have evidence or do we have evidence of HA? So I'm going to do these sort of together. So in part A, if we're using an alpha level of 0.05, we get a p-value of 0.013. So we compare our p-value to 0.05, and we can see that a p-value of 0.013 is less than 0.05. So in that case, a small p-value, you should say reject the null. And this is in a test to see if the mean metabolic rate is higher after treatment. So when we reject the null, if you think back to the previous page, what did that mean? That means that I'm crossing off the null and I do have evidence of the alternative then. So we would say, if we look down here in part A, that we have significant evidence of HA, and what HA was saying was that the population mean resting metabolic rate is higher after the treatment. If you're confused about what wording to use, a good suggestion is to look at what question you asked. We're trying to see if mean resting metabolic rate is higher after treatment, and yes, we have evidence that that is true. In part B, we're trying to see if mean body mass gain is lower after treatment, and we get a p-value of 0.007. So we compare 0.007 to our alpha significance level, 0.05. 0.007 is less than 0.05. We again would then cross off or reject the null. This would be from a sample value that's very far out in the tail, giving only 0.007 in the tail, telling us then that that sample value was not likely if the null is true, so we want to cross off the null. So again, if we reject the null, then we do have significant evidence of the other one, which is the alternative. So we would say as our conclusion down here that we have significant evidence that the population mean body mass gain is lower after treatment. And then the last one, part C, we were testing to see if mean locomotor activity is affected by treatment, and our p-value is 0.98. 0.98 is a very large p-value, so that is greater than our cutoff of 0.05, which means that our sample value is actually very likely if the null is true. So we would not cross off the null. So we'd say do not reject the null or fail to reject the null. If you are unable to reject the null, that also means that you do not have evidence of the research hypothesis or your alternative. So what we word that as then in part C here is we do not have significant evidence that the population mean locomotor activity is affected by treatment. So when we're finishing up our tests, we get our sample value, we get our p-value, then we use our p-value to either say reject or fail to reject the null, and then we state our conclusion in terms of our research hypothesis, which is HA, and whether or not we have significant evidence of that HA or that research hypothesis.